Okay, so let's talk about some details of the assignment for this module. First of all, if you haven't already, you should take a look at the Chapter 3 of the lab manual. It's posted in the assignment instructions and in the Module 1 main page. The goal in this first part of the assignment is to label the elevation of all of the topo lines in this map. The contour interval we're given is 40 meters. And so this one, the shoreline, which is at sea level, is therefore 0 meters. And I'll do the first one for you. The one next to it, in the uphill direction, must be 40 meters. Your job is to label the elevation of all of the other lines using the properties of topo maps that we've discussed. I'll give you a few hints. First of all, this one and this one, these bold-faced lines, are the same elevation. It's perfectly legal for two lines on the same map to have the same elevation. Second hint is this stream over here. This blue line represents a stream. And streams, as they flow downhill, they can join together, but they don't split. Say that again. Streams, as they flow downhill, they join together, but they don't split. So given that, you should be able to figure out which way the stream is flowing, and therefore which way is downhill on this segment of the map. The last hint is this feature here. Circular topo lines, like so, indicate a cone-shaped hill or a cone-shaped mountain. But if we're talking about a depression, circular topo lines, if we add in tick marks, as shown in this map, that indicates a roughly cone-shaped depression. Without the tick marks, they're regular topo lines. They indicate this is the uphill direction. With the tick marks, they point in the downhill direction. All right, good luck. In this part of the map, you're going to be using, in this part of the assignment, you're going to be using this map and these elevations to create the corresponding topo map. The contour interval here is 100 meters, meaning you're going to draw a contour or topo lines at 100, 200, 300, 400, all the way up to 700 meters. And so I'll do the first one here for you. Let's start at 100 meters elevation and draw the corresponding topo line for 100 meters. So the line starts here, passes through 100, I'll label it. And we need to pass through the points which are both larger and smaller than 100. So a 100 meter line must go through there. I don't see any points with 100, so I need to find the larger and smaller values. My 100 meter line must go through there. And 100 is a lot closer to 95 than it is to 60. So I'm going to draw it over here. And here I've got 210 and 107. 100 is pretty close to 107, so I think it goes over there approximately. And then it probably just goes off the map. So your job is to create the rest of the contour lines using this technique. This one was kind of easy because I had a starting point, the 100 meter point. Okay. There is no starting point for 200 meters, but we can kind of figure out where it must be. Here's 100 meters in elevation. Here's 290. 200 must be in between them somewhere, roughly in the middle. So my 200 meter line is going to be about there. I'll let you finish the rest. In this next part of the assignment, you're going to be doing a number of things with this topo map. One is calculating the regional relief, which is the difference between the highest point and the lowest point. Looking at areas which are steeper. Is A to B steeper, or is B to C steeper, using line spacing. And calculating the gradient. The gradient is a way of quantifying steepness. Gradient is calculated using 2 points. And you take those 2 points and you figure out the difference in their elevation divided by the distance between them, and then multiply that whole thing by 100. So a hypothetical calculation here, if I take these 2 points, that one and that one, my difference in elevation is, my first point is on the 900 feet line, so I subtract the other one to get the difference. The other one is on the 800 foot line. And the distance between them I figure out using this scale bar. This length represents 1,000 feet. And it turns out the difference between these 2 points is about 2.5 of those lines. It's roughly 2,500 feet, very roughly speaking. And so in my calculation, 900 minus 800 gives me 100, divided by 2,500 times 100. Turns out it equals 4, and this calculation produces results in a percent. Okay. This represents the steepness. For every 100 feet you walk sideways, to go from the 800 foot to the 900 line, every 100 feet you walk sideways, you have to walk 4 feet up vertically. That's what the 4% corresponds to. For every 1,000 feet you walk sideways, you have to walk 40 feet vertically. To give you a sense of scale, if you were walking or riding along a road at 1 or 2%, you may not even notice that it's uphill. You'll definitely notice when it starts to get up around 4 or 5 or 6%, and 10 or 12% will be really steep to walk or to ride a bike uphill. If you've ever driven up the Catalina Highway, up to the top of the mountains, up to Mount Lemmon, that highway goes uphill, and it's a fairly steady grade, and the average is about 4.5%, very similar to what we calculated here. The last thing you do on this map is think about how this landscape was created. It was created, or could have been created, by glaciers moving over the landscape, and the sort of details as to how to figure out what happened to create this landscape is explained in more detail in the assignment. Finally, you're going to be using this topo map to create a topographic profile. That is, what does the landscape look like if you were to go from A to A prime along this red line. In the example I gave above, we used a small piece of paper, lay it along the line, make some tick marks, write down the elevation, and then take that small piece of paper to the graph paper. We've made this a bit simpler here for you. We've taken the graph paper and put it directly below the map, so we can skip that middle step of the small piece of paper and just go directly from the profile line to the graph paper. And so what we do is from A to A prime, as you march across this red line, whenever you intersect a topo line, like there, 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 etc., you have to figure out the elevation of that line. And once you have that number, you go vertically straight down on the graph paper and put the dot where it belongs. So I'll do a couple of for you just to get you started. This line here is labeled at 700, and we're told the contour interval is 20 feet. So if this is 700 and this one over here is 800, it must be uphill in that direction. And so if this one's 700, this one must be 720, this one must be 740, etc. So this line, both of these dots there are 720, this dot is 740, and since this here is the 740 line, this one must be also at 740. So that first dot is at 740 feet. So I'm going to go straight down on my graph paper and put a dot approximately there at 740. These two dots, this one and this one, are at 720. So I'll go straight down on my graph paper, which is approximately there. Put the first dot, second dot, etc. Figure out the elevation of all of the topo lines where you cross them on the red line. Go straight down on the map and put a dot at the corresponding elevation. Connect the dots. That will tell you what this landscape looks like exactly from A to A prime. All right, the last thing we need to do in this assignment is calculate what's called the vertical exaggeration. The topographic profile that you drew in the last section shows the correct shape of the landscape, but the way it's been set up in this graph paper, that landscape has been stretched out vertically, shown the steep parts will look a lot steeper than they actually are, etc. So what we like to do is get a sense of just how much it's been exaggerated vertically. So we do that by looking at two things: the horizontal scale, that is something that tells us about the shape of the horizontal part of the map, and the vertical scale, the profile that you just drew. So we need to know the horizontal scale, and that's given to us here. It's written like this: 1 to 24,000. What that means is that 1 inch on the map equals 24,000 inches out in the real world. Or we could rewrite this 1 inch is the same as 2,000 feet. So there's a horizontal scale. 1 inch on the map, if you measure 1 inch on the map horizontally, that corresponds to, in the real world, 2,000 feet on that landscape. Our vertical scale we need to figure out. So here we're going to go down to our graph paper and figure out a similar 1 inch equals so many feet by simply measuring 1 inch on the graph paper and figuring out how many feet on the graph paper it corresponds to. So you're going to take your printout and get a ruler and measure 1 inch from the 700 feet up, and then figure out where on the graph paper that 1 inch lands. And so just hypothetically, I'm making this up. If you were to measure 1 inch is there, that's 870 feet. If we subtract where we started from 700 feet, your 1 inch corresponds to 170 feet of vertical elevation. Okay. And so your vertical scale, you're going to get 1 inch equals some number of feet. I'll let you figure that out. That goes here. And then our vertical exaggeration you calculate by taking your horizontal scale, which we figured out is 2,000 feet, divide by the vertical scale, which you're about to figure out. That goes here, and you'll be done. You'll get a number which tells you how many times the profile has been exaggerated or stretched vertically compared to the horizontal. Okay? So depending on how you print this and how your printer scales the images that you print, you might get a slightly different number than 70 than your neighbor, or from me for that matter. But roughly speaking, the vertical exaggeration in this example is about 15. If you get something wildly different than that, go back and try again on your calculations. Alright, that is the end of Assignment 1. When you're finished, please upload it to the Assignment 1 Dropbox, either as a Microsoft Word document or as a PDF. Whatever you do, please submit one file. What students like to do, which works very well, is to print out an assignment like this, take pictures of it, but please do assemble all of those photos into one file and submit that together. All right, thanks very much. Let us know if you have any questions.